I now want to look at surfaces of revolution in calculus, the end of calculus 1, sometimes the beginning of calculus 2. Here I've got a graph of y equals, looks like 1/2 x squared. We're going to have to use u instead of x for Desmos 3D to to cooperate. Anyway, so here we have that, and then what we do in that course is we find the volume of revolution by taking that and then wrapping it around the x-axis. And so then we have this object here, and then you can use any function you want. You can play around with this function if you want. You can make it 1/x cubed, let's say, and then it's a little more, it's a little steeper, right? And so essentially what we're doing here is we have our y equals f of u, not f of x in this case, and then we have our vector function u, f of u, cosine v, f of u, sine of v. So this is what's going on in the third dimension that is obtained whenever you rotate it about the x-axis. So once you rotate it about the x-axis, then it becomes a function in y and z. So we get, by calling it this, we get circles of radius f of u. Whatever your function is, that will be your radius. So wherever you're at along the x-axis, or u-axis in this case, that's what your radius is going to be. So if we go back over here, the radius changes depending on where you're at on the object. So notice that these circles are changing in radius as I go along the x-axis, in this case the u-axis, if you will. Okay, and so how do you create that? Well, go up here, you call your function whatever you want it to be. You can just make it u if you want, and then it's your cone. But I said initially u squared, so let's do that. So u squared, and then you give names to your traces. U is a constant, and then v is a constant. And we don't really need this one, I don't think, for this video right here. Basically, all we want to do is change a and b. So as I change a, I get more of it, and as I change b, I get more of its rotation about the x-axis. So you can see it like that. And then as I change c, if I zoom in a bit, if I change c, that shows you the circles being created along it. So you can play around with this with different functions, initial functions, and then different rotations about the x-axis.